Let's consider an example now dealing with lenses. So you have a converging lens, you know the focal length, you're going to use it for a couple of different experiments. In the first experiment, you use the lens as a magnifying glass to enlarge the image of an insect that has a length of 2.2 centimeters. So then we know we have a converging lens and we know the focal length. Now, in part A, our insect has a length of 2.2 centimeters. In terms of our symbols in our equations, we would say that's the object, and that's the height of the object, h sub o, 2.2 centimeters. Now, the first thing we want to figure out is we want to select an object distance that would result in the lens working as a magnifying glass and calculate the corresponding image distance. So we want to know what d sub o we can use so that we use it as a magnifying glass. Well, a magnifying glass is going to produce a enlarged image that is upright. If it's upright, it's also virtual. Well, our only option then is for d sub o to be somewhere very close to the lens. In fact, it's going to have to be between 0, or O, the optical center, and the focal length of that lens. Given that our focal length is 12 centimeters, anywhere between 0 and 12 centimeters, so I'm going to arbitrarily choose a d sub o value to be 10 centimeters. Now we want to use that to be able to calculate the corresponding d sub I. So then, using our lens equation, 1 over f equals 1 over d sub o plus 1 over d sub I, plugging in values, 1 over 12 centimeters is equal to 1 over 10 centimeters plus 1 over d sub I. All of my units agree, so I don't have to worry about converting from centimeters to meters. Doing the algebra solve down, we get a d sub I value of negative 60 centimeters. Negative means that that image is forming on the side the light does not go to. Okay, so that image is forming on the same side as the object. Now, the second part, calculate the image height. If we want the image height, h sub I over h sub o equals negative d sub I over d sub o, or hi ho equals negative di do. That's our other lens equation. So plugging in values, h sub I is what we want to calculate. H sub o, that was the 2.2 centimeters. Negative d sub I, so that's going to be the opposite of negative 60 centimeters, over d sub o, which we chose to be 10 centimeters. So then when we solve down for h sub I, 13.2 centimeters. Now, it is positive, and positive means that that image will be upright. Now, experiment 2 in part B. You use the lens to produce a reduced image of the same insect. So now we want a reduced image. Well, given that we have a converging lens, the only time we produce a reduced image is when that object is relatively far away, specifically beyond 2f. Okay, so f is 12 centimeters, 2f would be 24 centimeters, so then we need to be greater than 24 centimeters. So I'm going to arbitrarily choose a DO value that is greater than 24 centimeters. Let's go with 30 centimeters. Now, we want to calculate the image distance. So 1 over f equals 1 over d sub I plus 1 over d sub o. So this is going to be 1 over 12 centimeters is equal to 1 over d sub I plus 1 over 30 centimeters. When we solve down, that's going to give us a d sub I value of 20 centimeters. Now, in the next part, we want to calculate the magnification. Magnification, you're going to know that the object is larger or changed in size by comparing the image to the object. Now, that means we can divide the image height by the object height, or the image distance by the object distance, because those are equal to each other. Given that we know the distance is, I'm going to divide those. Image distance, 20 centimeters. Object distance, 30 centimeters. That's going to give us a magnification of 0.67 times. Okay, that means that the image is a fraction of the height of the object, so that means that the image would be reduced. In the third part on B, we want to describe the image. Well, our first descriptor is reduced in size. Now, if it's reduced in size, okay, it is also going to be real and inverted. The way that we know those are because your object is far away. It's beyond 2f, and for a converging lens, anything beyond f is always going to produce a real image, and real images are always inverted when they are formed by a single lens. Ponder physics.